So welcome students. So in this question you given that you have a pair of lines 6x square minus xy minus y square plus x plus 12y minus 35 is equal to 0. So I want another pair of lines which are parallel to this pair of lines which form a parallelogram such that the diagonals has to intersect at origin. So I want the equivalence of the pair of parallel lines to these lines such that the diagonals of the parallelogram which is formed intersect at origin. So how do I get the equation? So the first thing that I know is I want a pair of parallel lines. So this part does not change. So this pair of lines also have the quadratic part exactly equal to this. So just the point of intersection of this pair of lines and this pair of lines is different. So first step what I do is I'll try to calculate this point of intersection. So I know the midpoint, I know the diagonals bisect each other. So 0, 0 is the midpoint. From this I'll get this point of intersection. So once I get this point of intersection, so I have the answer. I can find the equation of the pair of lines. So first let us find the point of intersection of this. So what is how do I get the point of intersection of this? I'll differentiate this expression with respect to x first, then with respect to y, and I'll solve it. So 12x minus y plus 1 is equal to 0. This is the partial differentiation with respect to x. Then the partial differentiation with respect to y minus x minus 2y plus 12 is equal to 0. So now if you solve these two, so multiply it with 2, subtract one from the other, this becomes plus plus minus. So 25x, 12 into 2 is 24 plus x, 25. So minus 2y plus 2y gets cancelled. 2 minus 12 minus 10 is equal to 0. So x is equal to 2 by 5. X is equal to 2 by 5. So if x is equal to 2 by 5, so y is equal to 12x plus 1. That is equal to 24 by 5 plus 1, that is equal to 29 by 5. So this point is 2 by 5 comma 29 by 5. Now what is the corresponding point of intersection for this? So this pair of lines should be having a point of intersection such that the midpoint is origin, hence this point is nothing but minus 2 by 5 comma minus 29 by 5. So this pair of lines should have the point of intersection here. So hence the required pair of lines is nothing but, so you have 6x square minus xy minus y square is equal to 0. This is a pair of parallel lines with point of intersection as origin. Now I want the point of intersection as minus 2 by 5 and minus 29 by 5. So what I just do is I will replace x with x minus h, y with y minus k, that is x plus 2 by 5 whole square minus of x plus 2 by 5 into y plus 2 by 5 minus of y plus 2 by 5 whole square is equal to 0. So if you expand this, you get the required equation. So now this is one way to solve this question. So now let us look at an intuitive way to solve this question. So if you see this question, the basic thing that you need to do is, so you have a pair of parallel lines, you have a pair of lines, just need to get a pair of parallel lines whose point of intersection is the exact opposite of the original point of intersection. That is, if the point of intersection is 2, 5, 29 by 5, the point of intersection has to be minus 2 by 5 and minus 29 by 5. So for this you don't even need to find this point because the midpoint is origin, because the midpoint of the parallelogram is origin. So if one point of intersection is h comma k for this line, the other point of intersection has to be minus h comma minus k. So if let us assume that this pair of line is made up of a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. So let us assume that the first pair of lines is made up of these lines. Now I just want a pair of parallel lines to this such that their point of intersection instead of h comma k, they have to be minus h comma minus k. So if these two lines intersect at h comma k, what are the pair of parallel lines which intersect at minus h comma minus k? To have that, just need to replace x and y with minus x and minus y. So if you have a1 into minus x plus b1 into minus y plus c1 is equal to 0, a2 into minus x plus b2 into minus y plus c2 is equal to 0. So what is the property of this line? So if these two intersect at h comma k, these two lines will intersect at minus h comma minus k. So if you want a pair of lines which are parallel to a given pair of lines and having the point of intersection exactly opposite to the given point of intersection, what you just need to do is you have to replace x with minus x and y with minus y. That's sufficient. So the required equation is 6x square minus xy minus y square minus x minus 12y minus 35 is equal to 0. So this is the direct answer. So we can see this relation between these two lines. So even if you solve this equation, you get the same answer. Thank you.